Hi everyone, my name is Ihan. I'm gonna do the question 8 of homework 7, so let's begin. Okay, so for the subproblem A, it tells to find expectation of xt, and actually we know that for a Poisson distribution, the probability of x equals to k actually equals to the minus lambda's power of e times the k's power of lambda over fraction of k. And we know the expectation of this Poisson distribution is actually equals to lambda. So we know that expectation of xt is actually equals to the expectation of n0t, which is offered by the condition 1 of this question. Condition 3 of this question. So it actually equals to expectation of p lambda t, because we know the n0t is actually we can think it as a Poisson distribution where lambda is actually equals to lambda t here. So we know that actually here the expectation of xt will equal to lambda t. Okay, so that's the subproblem A. And for the subproblem B, it tells us to find the autocorrelation between T and T2, which is RT-T2. And so here we may first discuss when the T2 is larger or equal to T1. And I think T1, when T2 is smaller or equal to T1 is similar, but we can just think about the first condition here. For simplicity. So here xt1 equals to xt1 minus x0, and we know xt2 minus xt1, they are not having any overlapping times, so they are independent, which means the RT-T2 will, based on this definition, equals to the expectation of xt1 times xt2, and it will equals to xt1, and here we transfer xt2 equals xt2 minus xt1 plus xt2, minus xt1 plus xt1. We know it has the same value, so here we can just separate it because we know it's independent. So the first part will be expectation of xt1 times the expectation of xt2 minus xt1, which is this part, and we will have expectation of xt1 times xt1, and we will have expectation of xt1 squared. So we actually know the expectation of xt1 here. We also know the expectation of xt2 minus xt1. So all we have to calculate is the expectation of xt1 squared. And because it actually follows a Poisson distribution, as we discussed in the subproblem A, we know that the expectation of xt equals to lambda t, and we actually know from the property of Poisson distribution, we know the variance of this xt is also equals to lambda t. And we do have this property that variance equals to the expectation of xt squared minus the x square expectations, the square of expectation of xt. So based on this equation, we can calculate the expectation of x squared t equals to the variance plus the expectation square, and it will equals to lambda t plus lambda t squared, and will equal to lambda t times lambda t plus 1. So that's the value of this expectation of x squared t1. So then we can calculate this RT1, T2. It will be equal to lambda T1 times lambda T2 minus lambda T1, which expectation of xt1 equals lambda T1, and the expectation of xt2 minus xt1 is equal to lambda T2 minus lambda T1, and plus lambda T1 times lambda T1 plus 1, which is the expectation of x squared T1, and finally it will equal to lambda T1, lambda times T1 plus lambda T1 times T2. And as we said, similarly for T1 is larger or equal to T2, we can just follow the same step, and the final result will be lambda T2, lambda times T2 plus lambda times T1 times T2. And only difference is this. Here is T1 and here is T2. So we know it's actually equals to, here is equals to the mean T1, T2. So the final result of our T1, T2 will be equals to lambda times the mean of T1 and T2 times the lambda T1 times T2. So that's all for the question 8. Thank you.